Big thing to know with fibrous materials is that when you compress them, you lose R value. Okay? When you take a material that's designed to be 8 inches thick and have its R value, if you jam it into a 4-inch space, you reduce that R value. So the fibrous materials are designed to have that R value at that specific thickness. When you compress it, you lose insulation. Also, if it gets wet, you lose R value because you've got all those little air pockets, and now if you trade that air for water, you reduce the R value. Has anybody seen, I've seen mineral wool used on the exterior of the building. You guys know what I'm talking about when I say mineral wool? It's a fibrous material, it's kind of rigid, rare, very itchy. You think that product can absorb water? Do you think it's going to see water when it's in that space right behind the masonry? What is that going to do to the R value? It's going to lower it. So things can impact R value. Compressing the fibrous insulations, moisture if it's replacing air in the fibrous materials. Now the closed cell products, your spray foam on the exterior, the DOW styrofoam product, these are closed cell, which means that water doesn't have an impact on the R value because in these cells I'm trapping a gas other than air. That's how I get a high R value with these products as opposed to an R value of say 3 per inch with a fibrous material. Because the closed cell materials, we're actually trapping a gas that increases that R value. You guys are probably seeing this product. This is an expanded polystyrene. I call it the beer cooler insulation. If you've ever bought one of those beer coolers, how long does it last? Not very long, right? You put it down and it falls apart. Yeah, these aren't very durable. These are also kind of the open cell version of styrofoam, meaning this R value is created by trapping air. So that's why this only has an R value of about 3 to 4 per inch as opposed to 5 per inch with the styrofoam. This is closed cell, this is open cell. Does an open cell product, do you think it absorbs moisture? Yeah. Will this absorb moisture? Yeah. So will moisture impact the R value of this? Yes. So moisture's, and you'll hear that a lot in this, moisture is really the enemy when it comes to the building envelope. And it could also be the enemy when we're talking about our thermal insulation. But still dry air provides a good insulation value. So when we put that fiberglass inside a stud cavity, where hopefully it's not going to get wet, yeah, we get good R value out of there, as long as we're not compressing it. And the higher the R value, the greater the insulating power. Anybody here of U values? Okay, Chuck. We'll talk a little bit about U values. Basically, U value is the inverse of R value. So, not to get into math or anything here, but it's basically a lower U value is what you want as opposed to a higher R value. So it's just the opposite. The reason that we want to worry about U value is that, is our insulation product going to be our wall assembly? Or are we going to have other products in there like studs, like masonry? So when we're dealing with multiple products, more than one, that's when U value comes into play. And so in our wall assembly, we don't just get the R value from